Welcome to MCL306, Making IoT Smarter with AWS Rekognition. My name is Nick Robinson. I'm a software developer for AWS at our Herndon, Virginia office. To give you a little bit more background on myself and kind of the motivation for today's talk, I need to take you back to a year ago when AWS Rekognition was launched at re:Invent. I, like many of you in the room, got very excited about the product when it came out and set out to understand how I could use AWS Rekognition in order to build real-time applications that could perform object detection and classification, as well as facial analysis and facial recognition.
Sorry, we can't hear you very well.
Sure. Let's see if I can turn that up here. Can you guys turn me up in the back? Is that better? Perfect. All right, so I want to walk through today with some of the systems that I've built over the past year, help you get a better understanding of how you can build these types of systems for yourself. So by the end of this session, I want you to walk away with an understanding of how to leverage AWS, specifically AWS Rekognition and AWS IoT, in order to add intelligence to your IoT devices. We're going to build a couple of things today. We're going to build a smart door camera that you can use by indexing your friends and families into a face collection, and then using an IoT device to detect when your neighbor or friends are at your door. We're also going to build a smart object detector that I use to solve a problem that I was having in my house, but that can be adapted for any type of object detection and classification. And you're going to walk away with a reference architecture for how to build these types of systems for yourself. So here was my problem a year ago. And while she may appear very cute here, this is my dog Luna. She's also a master of disaster. And she goes around my house causing problems. Specifically, one source of friction between myself and my wife is that she goes into our guest bedroom all the time and rolls around on the bed, making a huge mess. So when Rekognition came out, I said to myself, aha, I finally have what I need to solve this problem once and for all. Now, my wife typically blames me for causing this because I have this bad habit of entering and exiting the room and leaving the door open. So I said to myself, you know what? I could build an application based on Rekognition's object detection features that could detect when my dog was present in the room. But I didn't want to just send myself the old way of detecting motion on an IoT vision sensor and sending myself a device. I wanted to get smarter and see if I could do it just when my dog was present in the room. So we're going to walk through how this system was built today. So this is the overall architecture of what I built. You've got your IoT vision device communicating with AWS IoT. It uses Lambda to interact back and forth with AWS Rekognition. And then we also have something I refer to as a delivery pipeline at the bottom of this slide. Now, I want to spend some time diving deep into each component so you can understand a little bit about how to get started with them and how they kind of fit into this architecture. So don't worry if you haven't spent too much time working with some of these components. We're going to spend some time diving into each one. So the first piece of this architecture I want to talk about is what I refer to as a detection pipeline. So what is this? It's made up of your vision sensor, IoT, Lambda, and Rekognition. And the first component of this I want to dive into is AWS IoT. And to really understand AWS IoT and the value it presents to you, you really need to understand a bit about the IoT industry as a whole today. So let's take a look at the state of IoT today. These are numbers retrieved from Gartner. And in 2016, Gartner estimates there were 6.38 billion connected devices online. And by 2020, Gartner estimates there will be 20.4 billion connected devices. You're also seeing growth in consumer spending that is tracking these same numbers. What does this mean for you or your company as you're trying to capture a larger and larger chunk of this rapidly expanding market? Well, customers' tastes are also changing in this market as well. Customers are expecting more and more for less. They want more features, more functionality in their IoT devices. And this presents some really unique challenges that you have to solve as an IoT device maker. So what are some of the common problems in the IoT industry as a whole today that you're having to tackle? So first and foremost, everyone's heard of the security challenges around IoT. So whether it's tens of thousands of IP cameras being exposed unintentionally on the internet due to not great out-of-the-box configurations provided by vendors, or whether it's things such as the Mirai botnet attack, where you had tens of thousands of IoT devices around the internet hijacked and used in a massive DDoS attack that knocked out wide swaths of the internet. It's very important that you take security into consideration when building these types of devices. And we think AWS IoT solves this problem in a really unique way. You also have to think, I would group the last two, the limited compute power and limited storage available on board with these devices. To touch back on the slide I mentioned earlier, customers are expecting more and more out of these devices. So as you're trying to add more and more advanced functionality, your hands are somewhat tied in what kind of or how much compute is available to you on these devices. So you really need a way to augment the capabilities of your IoT devices. And we believe AWS IoT allows you to do just that. So let's step back for a moment, take a 10,000-foot overview of AWS IoT. So with AWS IoT, you've really got three main groups of interactions. You've got your things, your connected devices that are connected to Wi-Fi or cellular networks, things such as smart temperature sensors, or maybe some machinery you have in your factory. These devices are communicating with the AWS cloud, and specifically AWS IoT, over a secured channel. And we believe this addresses the security concerns that we talked about earlier. So how is it secure? Well, AWS IoT and your devices communicate over a mutually TLS authenticated channel. And how is this done? Well, when you create a new IoT device, an X509 certificate and a private key are generated that you provision to your IoT device, and your IoT device authenticates to AWS IoT over mutual TLS. Once your devices are communicating with the cloud, you have a few choices of the protocol you use to interact with AWS IoT. First and foremost, most customers with IoT devices today are using MQTT, a really lightweight protocol meant for IoT devices that can offer 90% faster speeds than HTTP requests. But if you need to use HTTP or even WebSockets to communicate with IoT, that's an option available to you as well. And IoT will provide you a REST endpoint out of the box that you can use and send HTTP post requests to send messages to a topic that you've created. We're going to dive a little bit deeper into what those things mean here in just a moment. So once your messages come into AWS IoT, you can interact with the full gamut of services in AWS. So whether that's you're trying to capture analytic information on your device by writing records such as temperature data, any kind of sensor data to Kinesis, or if you're trying to take all these records collected from your IoT devices and do some type of batch processing using EMR. What we're going to focus most on today, though, is augmenting the capabilities of your IoT devices by using artificial intelligence. We think AWS has some really interesting offerings in this space, including machine learning. So imagine you're a device maker who's making machinery for a factory, and you're outputting diagnostic information on that machinery as it goes and sending that to IoT. You can use Amazon machine learning and train a model that can predict potential failures of that machinery before they happen. Or which the piece we're going to use today is Amazon Rekognition. You can add deep learning-based visual capabilities to your IoT devices easily in combination with AWS IoT. So diving into the middle component here, AWS IoT, what is AWS IoT made up of? Well, the main thing you need to understand is the AWS IoT Rules Engine. So you have your device out here to the left communicating with the IoT cloud. And you have the Rules Engine, which allows you to do three main things to messages that are coming in from your devices. It allows you to filter, transform, and react to incoming messages. So what do I mean by filter? So back to the example of you having a device in your factory that's sending a message about diagnostic information, including sending messages if for some reason the device fails. So you can specify a SQL select statement that will allow you to filter those messages out and perform some action only when you receive some failure event. The next piece of functionality is transform. And why is this valuable to you? So let's imagine you have an assembly line, and you have two devices that are communicating with AWS IoT. One of the devices sends a message whenever a job completes on your assembly line. And for some reason, you need to broadcast information to the next device downstream that job is just completed. but the next device expects a different format for messaging coming in. Well, these messages sent back and forth with AWS IoT are sent in a JSON format. So imagine you need some different key to be sent to the next device downstream. Well, with the SQL select statements you're going to see in just a moment, you're able to easily transform these key values into different names and then send them back out through what AWS IoT refers to as the device gateway to other devices downstream. You can also interact through what we call actions. So this gives you the ability to react to incoming messages. And these actions can interact with the services we talked about earlier, including SNS and Lambda, which really makes for an interesting use case that not only can you communicate with AWS services that we own, but let's say you own some endpoint on-prem that you want to communicate with. Well, using Lambda or SNS, you're able to easily interact with these external endpoints as well. So diving into the rules engine, what does a rule look like? Well, a rule is a JSON document that controls how the rules engine processes different messages. Here I've highlighted a rule to kind of explain it in terms of what we just talked about, of filtering, transforming, and reacting to messages. So you can see at the end here, I have this where clause added to my SQL select statement that's selecting messages where failure equals 1. And in blue, I have the transformation that we talked about. So we're transforming the key resource ID to ID and cycle to C_number. And then we could send that back out through some action to a device that we have downstream. So that's great. We have a high-level view of IoT. But I want to walk you through how would you go about onboarding a new device. In my case, how did I go about getting my Raspberry Pi that I use for this project up and going online and communicating with AWS IoT? So let me jump you into this video. And we can see at the beginning, this is what you get presented when you come into AWS IoT. What you're going to want to do is click on the Onboard button on the AWS IoT console. Once you do this, you're going to be presented with a page for a few options. I'm sure many of you have seen the AWS IoT buttons we have available. But for Raspberry Pi devices, you're going to want to click configuring a device and click Get Started. So once you click Get Started, you're given an overview of what's about to happen. So AWS IoT, through this wizard, is going to do a few things. It's going to register your new thing. It's going to allow you to download a connection kit that includes a device SDK of your choice. And it's going to configure and allow you to test your device. So it's going to run an MQTT client in the browser that's going to verify messages are coming in correctly from your device. So let's go ahead and click Get Started. And at this point, the device that I was using a regular Raspbian distro on the Raspberry Pi. So we're going to select a Linux OS X platform. And the device SDK that I chose to use was Python. So select Python, click Next. And at this point, you need to give your device a name. So for this, I just call it IoT Test. Now, a few things have happened for you. A thing has been created and registered with IoT named IoT Test. Sorry about that. And a policy has been generated for your device. So this policy out of the box will let your device subscribe, publish, connect, and receive to a topic that you have in IoT. You should likely restrict this policy to only the topics that your device should be communicating with. It also generates the certificate and private key that we talked about earlier, as well as it specifies that you're going to download the device SDK, and it includes a basic pub/sub application out of the box that you're able to run on your device. It also includes a start script to kick this off. So at this point, you can download the connection kit and get started. So we're going to click Download Connection Kit. That's been downloaded, and I'm going to copy it over to my device. You'll need to unzip the package. And at this point, you need to make the start script executable. And at this point, just to simulate a device coming online, I chose to use a Docker container that's using Debian in order to try this out. Oops. So once you run start inside the Docker container, it pulls all the required dependencies to get the application up and going. and it kicks off the pub/sub application. So now you can see it starts publishing messages to a topic called SDK/test/Python. And if we go to the next page, the verification page, you can see new messages are coming in from our device. And if we want to send a message back towards our device, we can type it in here. So I'm going to send hello world, and you'll notice here we see a message arrive with hello world in it. So great, my Raspberry Pi is up and running. I'm ready to send messages back and forth to my device. So the next component that we really need to understand for how to build the system is Amazon Rekognition. I'm going to skip Lambda for now, and we're going to come back to it and talk about how we glue these two components together. So at a high level, here's the functionality that Rekognition offers to you today. I'm sure many of you have seen this, and maybe some of you haven't seen. A week or two ago, AWS Rekognition announced text recognition API that you can call via the detect text method. We're going to dive deep today on a few of these pieces of functionality, including object and scene detection and facial recognition, which I used for my dog detector plus my smart door cam, respectively, as well as facial analysis. So the first piece of functionality I want to dive into is facial analysis. So at a high level, it lets you do a few things. First, it lets you understand the general attributes of a face. So maybe you're trying to gather data on whether the user has a mustache or has a beard or is wearing sunglasses. It also allows you to grab landmark information. So imagine you're running an application that you need to do content overlay on an image. You're trying to add advertising on top of an image that you sent in. Well, by getting this landmark information and bounding box information, you can intelligently place ads so that you don't accidentally lay them right over a person's face in the frame. But the piece of functionality with detect faces that gets me most excited, that I really like to use, is the sentiment analysis. There are all sorts of applications that you can build based on this. You get information back on the user sentiment or the individual sentiment, such as is the person happy? Are they sad? Frustrated? So you can imagine this in the context of a retail application where you have customer associates interacting with customers behind a register all day long. You could easily deploy an IoT vision sensor on the other side of the register and start capturing metrics during the day of how your customer associates are doing with the overall sentiment of customers that they're interacting with. We believe there are all sorts of capabilities and all sorts of untapped ideas that can be implemented using the Detect Faces API. The next piece of functionality I want to talk about that we use for the door camera is the Search Faces by Image API call. To use Search Faces by Image, you need to understand a few things about AWS Rekognition. So AWS Rekognition has this concept called a face collection. So what it allows you to do, it allows you to make a uniquely named face collection where you store information about faces that you're interested in. So you could use this to store the faces of VIP customers, persons of interest, or just your friends and family for a simple door cam application. You also have the ability to send in an image through the Search Faces by Image call. Rekognition will find the largest face present in the frame, and it will scan your face collection to find if there's a match. You're able to configure a similarity score for how confident you want Rekognition to be before it returns a result to you. And it can return as many results as you would like, I think up to 4096 or 4096 results. Another piece of functionality of Rekognition, and one that I use to detect my dog's presence in the room, is the Detect Labels call. So it lets you do some really neat things, and we have a lot of customers using this functionality, including a customer called Open Influence, who uses Detect Labels to index tens of thousands of social media photos to build a live visual search engine. So how do you interact with Rekognition? How do you interact with these API calls? Well, you have a few different options. The easiest is to just use the S3 abilities of Rekognition. You send in, you've got to specify your bucket name, your file name, and a version of your file. Rekognition will grab your file out of S3 and perform whichever API call you've requested. You can also do something really interesting, and you can send your image with the API call. So you can send the raw bytes of your image, base64 encoded, to Rekognition and get a response. There is one caveat here. there's a 5 megabyte limit on those files, whereas the limit for S3-based files is 15 megabytes. So this allows you to do some really interesting things. It allows you to take advantage of Rekognition, even for legacy applications or applications that you're running on-prem that you may not have in AWS, because you can send the image directly with your API call through Rekognition's stateless API. So what are some of the potential use cases here for the various APIs we've talked about? So you can do things such as build a smart body camera that'll alert when it sees a person of interest. Or you could build a dog bowl with an embedded camera that sends you updates during the day when your pet is spotted. By the way, if you build this, I will happily buy it from you. You can also do adaptive digital advertising. Imagine physical digital billboards that had an embedded IoT sensor that were watching as crowds pass by and calculating demographic information to choose what ads to show. You can also build really any vision system with configurable matching criteria. I'm going to show you how to do that in just a moment. So the next piece of the puzzle is AWS Lambda. We talked about actions earlier for AWS IoT, and one of the actions that's provided is Lambda. How do we go about setting that up? How do we make that work? So real quickly, I want to set up a new Lambda function and show you how you can wire it together to AWS IoT. So let me switch here. Great. So in the console, I've come to the Lambda console, and I'm going to create a new function. And I'm just going to base it off the basic Python hello world Lambda function. So let's name this new function IoT test. And let's just give it a Lambda basic execution rule. So I'm going to go ahead and click Create Function. And great, our new function has been created. But at this point, how do we wire this up to AWS IoT? So let's jump back to AWS IoT. And let's say we were on the home page that we landed on. How do we go about creating a new rule and assigning an action to invoke our Lambda function? So I'm going to click on Act, and I'm going to click Create a Rule. I'm going to name this rule IoT Rule, and just give it a description of IoT Rule. Now, we're going to need to do something here. We need to specify the SQL select statement that we talked about earlier. Now, I'm going to have it select any message that comes in on a particular topic, the one that comes out of the box with our basic PubSub application called SDK test Python. And now we need to add an action to the rule. So we're going to have it invoke a Lambda function, and we're going to call that Lambda function, or we're going to use the IoT test function that we just created. And at this point, we can create the rule. So we see the rule here. How do we see the contents of the rule? So I'm going to run this command. And we can see the output here. And it is the JSON syntax that we talked about earlier, including a SQL select statement, plus the action that we're going to invoke. So at this point, we have a Lambda up and running. But how do we modify this Lambda so that it's able to communicate back and forth with Rekognition with our image? So how we do this, there's a couple things we have to do. On your IoT device, because I wanted to use just a base64 encoded image in the API call, I pass the image when I detect motion on my IoT device. I pass the image in, base64 encoded. I send a MQTT message to my topic with a key in the JSON message that says image, and then my base64 encoded image. At that point, my Lambda will get notified. The event that comes into my Lambda will have my base64 encoded image, and then I make a call off to Rekognition asking it to detect the labels that are present in the photo. At this point, Rekognition will return to me a series of labels. I can filter those out by only the labels that I care about and choose whether or not I need to notify my device to write out the video of the event that it just saw. So we talked about already setting up a Lambda function, but what would our Lambda function look like to do this functionality, to detect my dog? Well, you'll see here at the top, I have an object list for person, people, human. How would I modify this to detect a dog, a shoe, a bed, anything you wanted to detect? So let me show you real quickly in the Rekognition console how you would figure out the right labels to use. Oops. So let's jump back here to the Rekognition console. And you can see I've sent my dog in, and I've gotten a bunch of labels back. But the labels I found most reliable for this application were canine and dog, so I went with those. So we'd modify the object list that we just saw to specify to only send a message back to our IoT device when a dog or a canine was detected. But you can use this for anything. You can send in any image you would like, get the labels back, and choose which labels to use to filter out the frames that you care about. Great. So at this point, we've got everything wired up, right? We've got Rekognition, our Lambda function talking to Rekognition, receiving frames from our IoT device, and we want to understand how this works. So let's see it in practice. So here's the console of me logged into my Raspberry Pi, my IoT device, my application up and running, communicating back and forth with AWS IoT. So you're going to see a frame here of my guest bedroom. If we give it a moment, you're going to see some motion. So you see some initial motion, and you see a motion was detected on the device, and it sent a frame off. Now motion was detected again, but this time the dogs are present in the room. So you'll see we got a message back that a dog and canine were present in the frame. At this point, it writes a video out to the device. We're done, right? Mission accomplished. We found my dog, we sent a video off, or we've gotten a video on disk, we're done. Well, not quite. So to really build the types of systems you see today, the kind of functionality you want a way to get notified, right? You want a way to send this message out to your cell phone, email, something. So I asked myself at this point, like, great, I have the video on the device, but how do I get it out to my cell phone? I really want to see the event happen and be able to do something about it. So this brings us to the delivery pipeline that's composed of your IoT vision sensor, S3, Lambda, and Amazon SNS. So let's dive into Amazon SNS real quick. What is SNS? So it's a scalable way that customers can send notifications to a variety of devices or endpoints. So you can send SMS messages, email. You can send HTTP or HTTPS notifications to an endpoint. And you can subscribe as many users as you would like, so as many cell phone numbers as you would like to a particular topic. So let me jump back real quick, show you how you can set up a new topic. So just open Amazon SNS. We're going to create a topic called IoT Test Topic. Create the topic. Jump into the topic, and we're going to create a subscription because I want to send a notification to my phone. So I'm going to select SMS. I'm going to give it a number, 1-555, 555, 555. Create the subscription. So at this point, we're done. All you need to do is publish a message to this SNS topic, and you'll receive a notification on your SMS device. So let's walk back. So great. The next piece of this is how do we get the notification out to SNS? So we have a video on our IoT device. We're wanting to get this all the way through to a mobile device. So what's the easiest way to get it out to our customers? Well, I found for this application, the easiest way to do this was using Amazon S3, specifically S3 events, and AWS Lambda. So in a similar way that you can trigger actions from IoT, you can trigger a Lambda function when a file is written to an S3 bucket. And you can also filter what kind of files would result in that event being triggered. So maybe you want to only trigger it, in our case, when an MP4 file is dropped in a specific location in your bucket. So let me show you real quickly how we set up this event. I'm going to jump back over here. Okay. So I've got an S3 bucket already created. It's called IoT Test Reinvent. I'm going to come in here to the Properties page and click on Events. So we're going to add a new notification, and I'm just going to call it IoT Test Event. And I'm going to have it fire anytime an object is placed in this bucket. But I'm going to have it only fire when the image is placed in a folder, in a prefix of images at the top level of the bucket. So I'll create a folder called Images, and when I push my file from my IoT device to the S3 bucket, I'll make sure it lands in this folder. And I can specify even the suffix and say, hey, I only care about MP4 files. At this point, you can select what to send the event, the notification to. And I'll choose a Lambda function. Now, I've already created a Lambda function called IoT notifier for this. So I'll save. Great, the event's created. At this point, let's take a look for a second at what that IoT notifier code looks like. So you've got your Lambda function that receives an event, receives this S3 event notification. And you need to do a couple of things to get this out to your customer. The easiest way I've found to do this is to use what's called a pre-signed URL. So S3 will allow you to make this call, generate a pre-signed URL that's SIGV4 signed that you can send out to a customer to allow them to have access to the file content. So what we do here is we go ahead and get that pre-signed URL from S3, and then we publish an SNS notification to the topic we talked about earlier. And we publish it with a message of click here to watch this video, and then you can tell it a human detected, dog detected, whatever you would like. So at this point, we got video getting pushed out to our mobile device. We can click on it, watch a video of what's happened. And the way I do this is on the IoT device, I keep a circular buffer of video. So when I receive the notification back from Lambda, I'm able to go back a few seconds before the event and a few seconds after the event. If you're interested in learning more about how to do this on a Raspberry Pi, I would encourage you to search Raspberry Pi motion detection. You can get a great tutorial about how to go about this. So what can we do to add face detection to this pipeline? As soon as I got this working, I thought, how can I take this device, deploy it outside my door, and do the same type of things leveraging the search faces by image call? Well, there are really only a few things you have to do to make this change. The first thing you need to do is build a face collection. So what I've done is I've created a face collection of myself and my wife at the moment. And I've leveraged a field called external image ID. This allows you to store metadata about a face. What I've done here is just put in my name. And then when I have my SNS event fire, it makes a call to search faces by image, checks whether or not one of these faces in the face collection is present in the frame. It also gets the external image ID, and it will transform it into our correctly formatted names and sends it out in our SNS notification. So let me show you just for a moment what the changes to the Lambda function looks like for this. So you can see it's almost identical to what we had earlier. We have our Lambda Handler, we have an image coming in, and we send off a base64 encoded image to the detect labels API. We have our object list here. What I found really reliable is using person, people, human. And at that point, we build our SNS client and our IoT client. We filter out the response from Rekognition to decide whether or not the labels that we have in our object list were present in the response from Rekognition. And if so, we go one level deeper. We choose to make a call to the search faces by image API. So we send off the image again, and we set the lowest threshold that we're willing to accept for matches. If we get a response back from Rekognition, we extract the external image ID I talked about earlier, replacing the underscore with a space and then capitalizing the string. And then we send an SNS notification out immediately. So I get a notification on my mobile device of who's present at my door. Then we send a notification back to our IoT device so it can build our video and then send it off through the delivery pipeline that we talked about earlier. So what does this look like in practice? So the same way earlier, we kick off the start script to launch our application on our IoT device. And it starts communicating back and forth with IoT. And at this point, it's waiting to detect any motion in the room. And you'll see it just detected motion. Oh, I'm sorry. Oh, here we go. So it kicks off our start script. It launches our application. It's talking back and forth with AWS IoT. And at this point, it's going to detect motion in the room, or detect motion at the door. And you'll see a detect motion event happened. At that point, the image got base64 encoded, sent into our Lambda, or sent into IoT, processed by our Lambda, which communicated with AWS Rekognition, It got the labels back, it detected a person was present, and it sends a message back to our device. You'll see at this point, it also sent back the name of the person it found in the frame. So it found a person, it sent it for one level deeper processing through the search faces by image API call, and it returned the name of the individual. It then sends a notification to my device. So you'll see Nick Robinson was just spotted at your door. And if we wait a few seconds, it writes the video out, and then it's going to send the video to the S3 bucket. An event gets triggered, runs our Lambda function, calculates the pre-signed URL, and sends us the video. And there it is, me walking in the room, and I return. So this is how you can kind of build these systems for yourself. There's a lot of additional things you can do for any type of object that you're trying to detect, or adding tons of individuals to your face collection. If you're interested in learning more about this topic, how you can build this for yourself in your own AWS account, I would highly recommend that you come out to the skills session tomorrow. There's going to be 3 sessions of SKL 69, where we're going to dive deep into this system, how you can build it for yourself, and how you can deploy it to your own AWS account. I'd love to take some questions. If you have any questions about the system, anything I can answer for you, I'd love to hear it. Just step up to the mic, and we'll get started. Thanks. Hi. So IoT recognition, or I'm sorry, AWS Rekognition can handle tens of millions of photos in a face collection. There is some marginal increase in latency. I'm not sure exactly what that profile looks like. We have a PM from Rekognition who may be able to provide more details as to what the latency increase looks like when you're working with larger and larger face collections. Hey, would you like to answer that question? So, the question was, what does this system look like as you're working against larger and larger face collections? Absolutely.
Check. Yeah, so last week we launched an update to Rekognition where you can now put tens of millions of faces in a collection, and will still do real-time search against it. So you'll get back results in less than a second. So that's the limit today.
Hello? Yeah, is there some kind of indexing method that you use to identify within a large collection like that? How do you actually, sort of identify buckets of these things to sort on and to filter on?
Let me see if I understand your question. You want to see the collection sizes, or?
No, I'm trying to just see what kind of algorithms you use to identify faces in under a second in such a large collection. How do you classify them, or do you classify them?
Right. So I mean, we have algorithms on the hardware side. We have done a lot of work to speed up these searches, make them parallel. And there's also other tricks and data structures that we use. So we've used a bunch of that, and it's definitely not something very simple to do. And that's why last week we released that update where you can now do this. So we have taken care of all the heavy lifting in the back end so that you can just run the search very fast. But there's a bit of stuff going on there. There's science on how to search faster. There's also some database stuff that we have done.
Is there any way to get started with AWS IoT without a physical device to connect to? Any kind of way to simulate a device?
So sure, you can interact. So like I did earlier, you could spin up a Docker container. You can interact with it on any device. There's a few ways to do this. So when you spin up a new IoT thing, you get a REST endpoint. You can interact with it by sending HTTP post messages to that endpoint. You also get a WebSocket endpoint that you can use as well. So if you wanted to build some kind of dashboarding application to get real-time, like build a real-time dashboard of what was going on with your devices, you can do that as well. So you don't necessarily have to have an IoT device in order to interact with AWS IoT. We've also seen customers use AWS IoT, spin up a new thing just to get the WebSocket URL to be able to use WebSocket, basically have a WebSocket server without them having to own the infrastructure. So that's another thing you can do with IoT as well.
So if I go back to my hotel and I don't have a device, will I be able to
Absolutely.
test it
So
out?
spin up a
Great.
new thing, you'll get the REST endpoint, and you can start performing HTTP post messaging. I would encourage you to try to get the WebSocket endpoint working, so do some client-side JavaScript. They show you an example of how you do SIGV4 signing when you're setting up that WebSocket connection. If you do that, then you could send a post message pretending like you were a device, and then you could see it show up on your web client in real time.
Thank you.
No problem.
So, one interesting thing you mentioned is Rekognition has the text recognition
Yes.
also.
Yes.
We wrote a project so I work I contract with NASA and we scan manuals. So we use Lambda and then we used OCR to scan those.
Okay.
And I'm kind of curious based on what you said, is it a way to use Rekognition as a way to scan all those documents?
So for doing OCR?
And then do an elastic search on that. That's what is ultimately the intended.
Yeah, I can take that. So the feature that we launched last week, it's called text in image, and it's targeted towards real-world images. So this is stuff like road signs or license plates, or if you have social media images where you can have quotes on top of an image and email address printed. It's not yet targeted towards documents. So today, if you put a structured document into it, it's unlikely to work very well on that. So that's something probably for the future, but today it's targeted towards real-world images. So if your use case is just structured documents and you want to understand the semantics, we don't do that today.
Thank you. But do you have OCR on your roadmap? Optical character recognition using Rekognition API? Is that
And
part
we
of-
have a long list of features that we want to build, and can't provide you any timelines. But I'll be happy to add your request to our roadmap.
For the face recognition and detection, apart from the network latency, how long does it take for the image recognition to provide a result? Do you have like a ballpark?
Right. So the real-time face search that I mentioned is obviously on the server side, and if you have a poor connection and you want to upload a large image, that's going to affect your overall latency. There's some tricks that you can do. So, for example, we accept images as S3 bytes as well as image bytes as well as S3 links. So if you're uploading from a camera, for example, you shouldn't write to S3 first and then read it back. You can just set the bytes directly. The other trick that you can do is if you have, let's say, a mugshot where a person's face is taking up, let's say, 80% of the image, you could downsize the image while not losing too much information. So the smaller the image, the faster the face will be detected. So that's definitely one trick. And on the search side, we have tried to make it almost stable, irrespective of the size of the collection. But network latency will play a role.
So you're going to downsize it either ways?
Sorry?
You're going to be, if we don't downsize, you're going to downsize on the server side?
Yeah, I mean, we have different techniques we do on the back end, but if you provide a smaller image, it's obviously going to be faster. Because, and that's only for the detection part, though. For the search part, we use face vectors, so it doesn't really affect that piece.
Okay.
Because when you do search faces by image, the first step is to detect the face in it, and then it searches against the collection. So as long as you can control the latency for the first step, I think your overall latency should be pretty good.
And if customers are using JPEG images, they can do a decent amount of compression on the image as well in order to reduce the
Yeah.
size of the
You could do that.
sit through.
Yeah.
Sounds good, thanks.
I have a two-part question.
Okay.
So I'm assuming that you are using some kind of triplet loss or equivalent algorithm in order to come up with a 128-dimension vector recognizing the person's face, right? Is that how you're doing the face recognition?
So, I mean, without going into the details of what exactly we are doing, we do use a bunch of the latest techniques, like some of the things you mentioned are things we have looked at.
Okay.
There's there's some standard literature around it, but we also do
Some
more stuff on our end to look at that. And data, of course, is a very big piece of it as well.
obviously.
Because architectures are getting standardized. There's some secret sauce in there, but the data is where I think you'll find a lot of differentiation as to how large your data sets are, how varied they are. And we hear from a lot of customers, a lot of use cases, and that helps us to continuously improve the product based on all the feedback and the examples that we get. So that's what you get from Rekognition, a combination of all of that. And our scientists are continuously training new models, so we are usually at the state of the art.
So that brings me to the second question. So once my face is recognized, right, it's almost like for lack of a better term, it's like a social security number, and the next time my photo is, or I'm seen, the algorithms can immediately recognize me. So do you have anything like do not track, or more broadly, what are the kind of privacy settings that are possible with the APIs, or there are none?
So the data in the collection is owned by the customer. We don't look at it, and we have some safeguards there as well as to if somebody wants to opt out of data being stored and all, we can do that. But in general, I think in this case, when the customers are building using Rekognition, we depend on them to, if there are laws that they need to follow as to how they're storing the images and using that, that would be definitely there. And the rest of it, I would say, depends on the legal contract there, so can't really speak to that.
Okay, fair enough. Thank you.
So from what I understand, you send the image from the device into a Lambda function using AWS IoT, right?
Correct.
But I think I read in the documentation of AWS IoT that for the message, there's a payload limit of 128 kilobytes, I think.
Yep.
So how did you do that?
Go ahead, I'm sorry. The way I handled this is doing a large amount of JPEG compression and running the camera at 720p on the device.
17.
Yes. If you want to go higher than this, I would encourage you, if you're able to, from your IoT device, use the full gamut of AWS services. Maybe you want to consider another way of sending these messages via SQS or using the S3 event trick that we talked about earlier. But this works great for 720p images, and for the distance that I'm running this application in a really fixed environment, 720p has worked great for detecting the dog or detecting anyone walking in those confined corners or confined space. If you have a much larger space that you're working with, likely you're going to need more pixels, and you'll likely have to investigate some other alternatives for getting your image data, your frame data, to your Lambda and to AWS Rekognition.
So you're actually sending the image less than 128 kilobytes.
Correct.
I see. Do you have any idea for other alternative if my image is bigger than that?
So there's a lot of things you could do. You could send the message in through Kinesis. You could send the message into an SQS queue, which could cause a Lambda to fire, and then you could send the message off to Rekognition. Or you could use S3, just like we talked about earlier. You could write the image out to S3, have an S3 event that's waiting for a new file to arrive, which triggers your Lambda and causes your Lambda to interact back and forth with Rekognition. At that point, you might be better off to just use, or you would be better off to just specify the S3 information so that Rekognition can look up your file, because you would already have it stored in your S3 bucket.
All right, thank you. If I may, for a second question.
Absolutely.
So from what I understand, you first do motion detection on the device, on the Raspberry Pi, I think.
Correct.
With some applications, with some algorithms.
Yep.
And then you just start sending the image when you already detected the motion. Is that
Correct.
right? So what if I want to just send all the images, like just stream the image continuously from the device onto AWS IoT?
So-
Will I be limited with some kinds of limits, like maybe bandwidth or something on the IoT side?
So I'm not sure on the limit in terms of the number of messages, so I would refer you to the AWS IoT documentation for limits. However, if you're sticking under that 128K message limit and you were willing to tune down your FPS to, let's say, 10 or 15 FPS, I see no reason why you couldn't continuously send your frames off. As long as your IoT device has enough compute power and you have enough bandwidth to push all of these images off and keep up with your real-time stream, I see no reason that wouldn't work.
Okay, thank you.
Hello. Was wondering what kind of cameras would Rekognition work with, like IR cameras, for example, and how might that impact like your precision recall?
Sorry, I couldn't hear the question very well.
Would Rekognition work with IR cameras as opposed to visible?
Not today.
Okay. And can you share some precision recall numbers as far as with the visible cameras that you might have?
Precision recall numbers for what?
For the facial recognition, like on the image search.
So that's not something that we put out. I mean, we always encourage customers to measure it on their own end as well.
Okay.
On our side, when we test, we always, as I said, we are training new models every so often, and we are at or near the state of the art. But then what we're really concerned about is how does it perform for the customer's data and their use case. So something in this area is that you could always train a model. It could do very well on academic data set. But what matters for customers is how does it perform on a real-world data set. So that's why, even if I put out a number, it's very specific to the use cases that we have looked at. So we always tell customers to test it on their own end and then provide us feedback as to how good it is. But from our side, when we measure, it's at or near the state of the art.
Okay. Thanks.
Hello, I'm interested in the detect labels functionality, how powerful it is. If you, for instance, upload a screenshot from a video game, can it use that? And if the labels that I'm interested in are not detected, is there a way to sort of train it to sort of find stuff that I'm interested in?
I'm sorry, I didn't get the first part of your question. Could you repeat that?
Can it detect images from video games?
Sorry?
Can it detect images? So let's say you had an image from a video game and send it through. Would it detect labels for that image? And also, if not, can you train it to find those types of labels?
So not today, but what kind of labels would you like to see in a video game? I could take that as some feedback.
So I work in anti-cheat. So when we get a report about a player, we take a screenshot, and often these players, when they have a cheat, they have boxes around the other players in multiplayer games. So I want to use that. So currently they are reviewed manually, but I am wondering if I can sort of automate this process.
I would love to talk to you offline and take the request as to what kind of labels you would like to see in a video game. That would be very good feedback for us.
Okay. Thanks.
Hey, my question was partially covered, I think, by the others, but still, I'd like to ask about live tracking objects in, say, a video feed. So I have one rather specific use case. I need to be able to track hot dogs in a video stream.
Okay.
Let's not go into details of that, but in any case, obviously the round trip through to Lambda and the Rekognition and back will take a while, which will drop the FPS to, say, like 10, basically.
Okay.
And that's a bit too slow for what I'm doing. Is there any way how to, let's say, export classifiers for specific tags out of Rekognition?
So, go ahead.
So your question is there a way to export the classifier
Yes.
onto a device?
Yeah.
Yeah, not today.
Okay. Is
But
there any
again,
plans
happy
for
to
it?
take the feedback and as a feature request.
Yeah, that'd be cool. Thank you.
My question is around age. So if I have two images and I want to know whether it's the same individual, and today, like how close, like if it's a child and they grow, or it's a middle-aged person, they become elderly, how close of an age does it have to be for that level of accuracy?
So you're talking about accuracy of the age detection itself or a facial search under different ages?
Like if I had two photos of the same person, and one picture they're 20, and the next picture they're 60.
So that's the facial recognition piece then.
So is there any concern with that working?
Yeah, so there's of course, we have tested it on certain age ranges, but that's a challenging problem in general. If you have somebody's face from when they were 20 and now they're 60. I think the science itself for that is still evolving as to how to create data for that and look at how faces evolve. So I would say you should try out for your use case and see what happens, because there's obviously some generalization ability built in, but a very wide age range is likely to cause some trouble, I would say.
I would echo that. So I found in practice, I built a little application inside of Amazon called Doppelganger that would compare employees, and it also had employee information from the past.
Yeah.
And so across 5 years, 8 years, had a really high match rate. I don't have any exact numbers to give you,
Sure.
but in practice for that kind of range, I found really, really great performance. But I haven't done anything as large of a gap as what you're talking about.
Okay.
But as I said, the science is still evolving, and we keep improving the algorithms. So hopefully in the future, we can keep narrowing that gap.
Okay, thank you.
Awesome. Thanks. Oh, there is? Sorry.
So I was wondering if you guys have a pattern for creating custom labels. So let's say, I don't know, you want to identify specific products that your company manufactures or whatever it may be, or the competitors. Is there a pattern that can be used with either with Rekognition, or would it have to be like a custom trained model?
So not today, but I would like to hear more about what the use case is. So you want to actually train the system with your own data, or?
Yes.
Okay. So and these would be product images, or what kind of labels are you looking for?
So there could be two cases, but the simplest one would be basically, let's say you have a company that manufactures certain products, and let's say, I don't know, you have somebody who walks in the stores, for example, and takes pictures of the shelves, or has a live stream, right? And you want to pick out where those are. And then a more extended use case would be where you actually have planograms for the shelves or the aisle, right? And you want to validate that the products, specific products, are positioned in specific places. So that's a kind of an extension of the first.
Yeah, that's a great feature. So I'll take that feedback and add it to our roadmap for sure.
So, but there isn't anything that, so the way I would do it without Amazon existing services, right? Basically, you would have to set up some kind of model. You would train it, right, on the site. But that's
so on AWS, you can definitely go in today and use frameworks like MXNet, or if you're a fan of TensorFlow, we do that as well. So we have a deep learning AMI, which you can just spin up an EC2 instance, get some P2s going, and spin up that AMI. It has the latest versions of all these frameworks, and you could train it fairly easily there. So if you're a data scientist who's familiar with the workflows and wants to build a really customized model for a specific application, we have many use cases like that running on AWS. So we always recommend to customers who have very specific applications and have the data for it and understand the science behind it to train a very custom model for that. Because we'll keep adding such things to Rekognition in the future, but as of today, it's a pre-trained model. So if you have a very specific need, today the best option might be to just use something like MXNet, put your data in, and train it.
If you're looking to do this in the context of IoT devices, I'd point you towards a blog article. If you search Raspberry Pi SqueezeNet AWS, you'll find a blog article that was written about how you do exactly this. You use MXNet to train a SqueezeNet-based model. It's a really small, much smaller convolutional neural network that you can deploy your model to an IoT-type device and get pretty good results with it, with much lower latency than you'd get for a lot of traditional convolutional neural networks.
It has a much smaller memory footprint as well, so there are techniques you can do like that.
Okay, can I have one more question? So do you guys have a pattern for offloading it ties to a previous question, to offload the Rekognition to the IoT device?
Not today. So the classify export, as the previous question was asking.
Yes, so either the classifier or even for, let's say you use your own trained model, but is there any, well, I guess Yeah, it's a more complicated
Yeah,
implementation.
not today.
On the IoT.
Today we are a cloud service. That's a different flavor altogether.
Yep.
So
Agree. Okay, thanks.
I'm just following off of his question. Do you have the ability to identify consumer products like you sell at Amazon?
no, not today. Our labels are general objects and scenes. Specific products and their variants are not supported today.
Okay, thanks.
For the skills session, you have to sign up.
Yes.
The app doesn't allow you to sign up. Is it like a follow-up sheet? Is it a sheet or?
Let's follow up, and I will find out for you. Awesome. Thanks.
Thanks, everyone.